Hello and welcome to the podcast. I'm Steve and I'm here with Bill. Good morning, Bill.
Morning, Steve.
This is the Field Guides. So what we do on this podcast is we pick a nature topic, we research that nature topic, then we bring you out to the field and tell you everything we learned about that topic. I said topic a whole bunch.
You did, but that's okay.
Okay. All right, Bill, what are we talking about today?
Well, today we are talking about a plant that has a very interesting natural history, but it's a very common plant.
Yep.
Especially along roadsides and open areas. But I want to start by asking you, Steve.
Sure.
What do you think about hallucinogenic plants?
I've never... Now, mushrooms. No, I'm kidding.
Before I get into the story,
Sure.
You know, you're familiar with the golden guides, right? Like
Yeah.
The golden guide
Golden
to
Guide to
birds.
Birding, yeah.
So were you aware that there was a golden guide to hallucinogenic plant?
No,
Yeah,
I
a golden
didn't know
guide
that.
to hallucinogenic. It is no longer in print.
Right.
But I had a friend show it to me a number of years back, and before this episode I looked it up online, and I couldn't find a copy readily. I'm sure it's out there somewhere, but it was printed in the 1970s.
Mm-hmm.
And it's a little tiny golden guide. It almost looks like a kid's book, all
Sure.
about hallucinogenic plants. And the plant we're talking about today is a plant with supposed hallucinogenic properties. So we were talking about sumac today, and specifically Staghorn Sumac.
Yeah.
Rhus typhina,
Mm-hmm.
right? Now, the leaves of Staghorn Sumac are said to be hallucinogenic.
Oh, that's interesting.
Yes. Now, I've tried it. So back in my college days, on one of my college classes, we actually took a trip up to the Adirondacks, and this was told to us by our instructor.
And you all got stoned. I knew it.
One of the students harvested some sumac leaves, dried them, and we tried to smoke them. And I can report that I had no effects whatsoever. I don't know if it needs to be the fresh leaves or not. I never tried it since then. But it'd be interesting if anyone out there has ever had any effects from sumac. I'd be interested to hear if that is true or if this is just, folklore that has no basis in fact.
Or if you know a guy, we can get some.
I know a guy. He can give me sumac. Now, before we
I
start,
need my sumac fix. Yeah.
before we get into the sumac, though, why don't we tell people where we are?
Oh, yeah. We're at a place called Majors Park.
Yeah. And this is located just outside the village of East Aurora.
Mm-hmm.
For people who don't know, that's the birthplace of the arts and crafts movement.
Oh.
We should say it's the birthplace of the Roycroft movement.
Okay.
So that was from earlier in the 20th century. It was all about crafts and leading a simple life dedicated to craft. People do from all over the country. They come to East Aurora just to look at Roycroft history.
Right.
But a number of years ago, I think within the past 10 years, some citizens in the town got together and they decided that there was a nice patch of relatively wild property that they wanted to turn into a park rather than have it developed for more housing.
Mm-hmm.
So you have a mixture of wetlands here. There's some riparian habitat. It's mostly second growth woods and reclaimed farmland.
So there was a creek that ran through the back
There
of this?
is. There still is. People actually do some kayaking on it. But
Nice.
to give people an idea of what we're standing in now,
Yeah.
this is mostly, we have lots of low shrubs around us.
Yeah. Honeysuckles.
yeah.
It's Staghorn Sumac right next to us.
Right. And then there are some trees, but I'd say this is more of like an edge habitat here than,
Right.
yeah.
Yeah, and this doesn't look like it's too old of a place. It's either they're not very tall trees
No.
or they're not very old trees.
No, there's a stand of maples nearby, and they look...
How high? 50 feet?
yeah, maybe 50 feet. So they look relatively young. So this is going through succession right now. It's in a transitional state,
Right.
heading towards forest. But the path we're walking on right now has our target species right next to it.
I think this is our best bet right
Yeah,
here.
I think so too. So Staghorn Sumac, if you don't know, it is a small tree.
Mm-hmm.
And should we get into the difference between a tree and a shrub?
If you want to. I don't know much other than there's a bit of a height difference.
Yeah.
And
So
yeah.
it's debatable
Yeah.
what's the difference between a tree or a shrub, but many definitions that I found in researching said a shrub has a maximum feet around 13 feet.
Mm-hmm.
And at 4.5 feet, which foresters call diameter breast height, it's where they do usually measuring trunk diameter,
Right.
you're going to have one main trunk usually, or I'm sorry, with shrubs you're going to have multiple main trunks.
Should we say spoiler alert first? Or?
Why?
Well, you're giving away... What if they haven't read the book?
What book?
Well, anything. What if they haven't read the study? Okay, well, read the study and then
This isn't a study.
Wh-
This is me just talking about the difference
How
between
did you
trees and
learn
shrubs.
it?
Oh, I looked at a whole bunch of different websites.
Okay, fine. All right.
Are you just being difficult? Steve's just being difficult.
Right.
All right, so at 4.5 feet, you're going to have multiple trunks on a shrub usually, and the
Sure.
diameter is going to be 4 inches or less, or less than
Gotcha.
4 inches. So with sumac, that's generally what you have. You have multiple thin trunks.
Okay.
It tops out around 15 feet or so.
I've seen so many different ranges. In one of my field guides, it said up to 50 feet tall. In another field guide, it said up to 30 feet tall. But I think I even saw it could be a tall shrub or a small tree.
Okay. Yeah.
Which, so
There's some
much
overlap
overlap
there.
You're right.
Now, the stand of sumac we're looking at, I'd say from one end to the other,
Sure.
you're probably about 100 feet or so. And it has like a domed appearance.
Sure.
Why is that, Steve?
Spoiler alert. A Staghorn Sumac is actually a cloning species.
Right.
So one big aspect of that is that you're either going to get female clones. Oh my goodness.
Uh-oh.
Okay, yeah, female clones or male clones. So the trees are they're not bisexual.
Correct.
So they're either male or female. But the flowers are actually really cool. They have vestigial sex organs of the other sex on the flower. So if
What?
it's a
Really?
female flower, it has these vestigial male parts. So vestigial anthers and whatnot.
I did not know that.
Right. But another interesting thing about the flower, and I have a book, Botany in a Day, but I also have Botany Illustrated. Incredible books because they give you everything you need to know about all these different families. But they actually show a good diagram for the flower of Staghorn Sumac. It has it's a 3-parted carpel. So the female part of the plant is fused carpels.
Okay.
But it only has one seed cavity, so only one seed develops in each flower. But you would have gotten that, or because it's a drupe, so it's still just the one seed. But I thought it was interesting because a lot of times when you're walking around and you're seeing plants and you're seeing the seeds that they're putting out, if it's a fused carpel, let's say if it's bicarpellate, it's going to have 2 seeds in it, or if it's tricarpellate, it's going to have 3 seeds in it. But even though this is 3 fused carpels,
Hang on, Steve. Shut up for a sec.
white-throated, Zonotricia albicollis.
It is.
Yeah.
It is a white-throated sparrow feeding on the sumac. His nice little white patch under his beak.
I love white-throated sparrows.
I was just being funny when I would tell you to shut up.
That's fine. But I was just saying it's a fused carpel. It's got 3 carpels fused together, but it only produces 1 seed,
Now, what
which
is
I
it-
think is interesting.
What is a carpel for people who don't know what a carpel
So a carpel, that's the area of the female part of the flower where the seed will develop. So that'll have the ovary, that'll have...
Yeah.
Well, either way, that's where the seed develops. So
Yeah.
think of a cherry or think of
peach.
peach. Yeah.
So
Yeah.
I wasn't going to talk about drupes yet, but why don't we jump ahead then?
I did want to add in that what the family is, the Anacardiaceae.
Yes, okay, good. We'll talk about that.
So that's the sumac family, but it can also be known as like the cashew family. It includes plants like mango,
Yeah.
right? Mango.
I didn't know until I did the research.
I
for
did
this,
not
that
know
was
about
in there.
mango.
Yeah.
Yeah, poison ivy, sumac, pistachio.
Yep.
And then there's a few more, but those are really the best known ones. And also Staghorn Sumac, Rhus typhina.
You say Rhus or Rhus?
Rhus. Well, I think it's Rhus. I think
Okay.
I meant to say Rhus.
Right.
So poison ivy and poison oak were previously in the Rhus genus, but now they're in Toxicodendron.
Right. And
Yeah.
all of them, though, are still members of the cashew family.
Yes, they're
So,
all.
it
Yeah, they
has a-
changed genera, but they're still in the same family.
Right.
And one actually interesting thing about the differences between the genera is that all Rhus fruits are bright orange.
Rhus.
All Rhus fruits are bright orange, and all Toxicodendron fruits are either white or yellowish berries. So there is like a phenotypic difference between the genera.
But these aren't orange.
Oh, when they're in their prime, they're like a bright dark orange. Some of the pictures I've seen look really orangey.
I'm talking about the ones in front of me.
I think there's some variation. These look maroonish, really.
reddish.
Yeah.
All right. I think they're red, but
Well, maroon. It's also sort of dark in the wintertime.
No, they're red!
Under the right lighting, who knows what they are, really.
I fondled many a bunch
Oh my
of
God, don't finish that statement.
I fondled many a bunch of Staghorn Sumac berries. They're red.
Yeah, well.
All right. So anyway, though, Toxicodendron. There is a sumac that is poisonous.
Okay.
Yeah. So Toxicodendron vernix.
Oh, I didn't know that.
So that's poison sumac. You know about poison sumac.
Well, yeah, but I didn't know that it was a... Oh, right. I don't know what I was thinking. Okay, go ahead.
But I find when I talk about sumac to people, even people that I think would know quite a bit about nature, they assume that this sumac, Staghorn sumac, with the clusters of red berries they see along the roads, they think that's poison sumac.
Oh, that's weird. Yeah.
Have you
Well,
run into that where people get confused?
I don't know. I don't really hang out with people that don't know a lot about plants. It sounds bad, but as you get older, sometimes certain people sort of fall off your radar, and you're so closed in by like-minded people sometimes.
Well, let's point out that poison sumac is in a different genera. It is in the same family, the Anacardiaceae, the cashew family, but it's in a different genera, Toxicodendron, and it has white berries. And it really only grows, I've only found it in habitat descriptions, I've only found poison sumac growing in wet, swampy areas. I've had more than one person tell me if you start to fall or sink into a swamp, the first tree you grab for will be poison sumac. That's going to be the one you grab onto. Wow. So Staghorn sumac, though, I think it looks like almost nothing else.
No, I can't think of anything else that it would look like.
A small tree. It has that clonal domed appearance. Yeah. And then these clusters of furry red berries.
Something interesting about the way the tree is shaped, it has this flat crown. There's these stout branches that end almost like in an umbrella. And every tip, I think every branch ends in a fruit.
Yeah.
Yeah,
it does seem that way.
It's crazy, yeah. And that's like nothing else really has that look that I know of.
You're not going to find skinny sumac branches. Yeah. Now, what I was going to say before was that the other species of sumac, do you know that we have fragrant sumac here in Western New York? We have smooth sumac here in Western New York.
I know that it can hybridize with smooth sumac, but I don't think I've come across smooth or
but
fragrant.
But on USDA plants, there were accounts in Erie County, Chautauqua County for smooth sumac and fragrant sumacs in Niagara, Orleans County. All these are all counties right around us.
Or we can ask the Botanical Society and they can tell us where it is.
I've never
Knowingly?
noticed it.
Right.
Yeah, so maybe I've seen it and said, oh, look, sumac, and just assumed it was Staghorn sumac.
Right.
But let's do some general description, though.
Sure.
Why is it called Staghorn sumac?
Oh, yeah. If you look at the branches, they're covered in this really dense, woolly...
Velvet.
Yeah, it's like a velvet, right.
So like a deer antler.
Like the velvet that a deer gets on its antler that it sheds off in
fall.
The
We'll
fall.
shed them in
the
fall, early winter.
You find it.
All right, so the clusters of berries, those emerge during the summertime. And like you said, on certain clones, those are going to be the male. Those clusters of flowers will just release the pollen. Right. And then on the female, like these are all females in front of us here because they bear the fruit.
Yes.
So
you'll usually find a bunch of females together or a bunch of males together. So, I wonder if I've ever come across a stand of sumac that I didn't even realize was sumac because it was all males.
You probably
if the flowers had already
Yeah, because if
fallen.
it's during the winter time and there's no leaves on it,
right.
You're just assuming, oh, it's sumac or I don't
Although,
know what it is.
It's very rare, but sometimes a plant will arise that has both male and female parts. But that's from the study that I found this in. It's less than 2 plants in every 1,000 produced.
Oh, wow. Okay.
So it's a very small.
Less than 1%. Yeah.
Oh no, less than 1%, but it's less than 0.2%. Yeah.
It's tiny.
Yeah.
I do want to say the leaves of this are compound leaves. So
feather pinnate or feather
pinnate.
Compound.
That's right. Yeah. So just like we were talking about with multiflora rose in the last episode, if you were to pluck a leaf off where the leaf stem, the petiole, attaches to the stem, you would be holding in your hand what seems like a cluster of leaves, but that's a compound.
It's almost like
leaf.
A branch with a bunch of leaves growing off of it.
So you're holding the petiole in your fingertips, and then the leaf stem that goes up is going to have lots of leaves coming off of it, as you said, in a feather pinnate arrangement. Right. And the leaf itself can be 12 to 24 inches long, so it can be 1 foot to 2 feet long, and it's going to have, gosh, how many leaflets?
I had 7 to 31 leaflets.
Whoa.
I think there's a huge...
That's a huge range.
Yeah.
Yeah, so there's usually a lot.
And we've talked about this before. I think in the Fall Colors episode, we talked about ash trees, so we described what a compound leaf is before. Yeah. But the big difference, well, other than just looking at the tree, there's a huge difference. But the big difference in the way the leaves are arranged on the tree is that in Staghorn Sumac, they're alternate. So they stagger on the branches. Right. They're not opposite of each other coming off of the branch. Right. If you remember that from episode 2, and if you haven't, go back and listen
to it. Now, do you know about foliar flagging? You must have heard about that.
Yeah, I know about this.
So Staghorn Sumac, in the fall, the leaves turn this vibrant red color.
Right.
And that's flagging for the animals. Is trying to flag the fruits that, hey, come on in here. Our fruits are ready to be dispersed. So that's the foliar flagging aspect. Now, getting back to the hallucinogenic thing, I did have someone tell me once on a hike when I told them that story.
Sure.
They said, "Oh, you got to harvest them when they're red. That's when they're the most hallucinogenic."
Yeah, some people have these ideas. Who knows? Maybe there is something to it, but...
Now, I will say this is not study-based. It's not based on a scientific study, but Staghorn Sumac leaves, it has been historically, through historical accounts, it's been found that it was a component of many Native American groups. It was a component of their tobaccos.
Okay.
So have you heard of kinnikinnick?
Yes. So it's like a small, really low-growing shrub. Or
It is.
It's not a shrub. Sorry, it's a low-growing, spreading
herbaceous
plant.
plant. Now, there's different plants that have that name, but it is also the name given to different combinations of tobacco and plants that Native Americans used. So say the Delaware Indians, that would have lived further east of here, closer to the Atlantic, they would have had a particular combination of kinnikinnick.
Okay.
And then other groups around here would have a different mixture. Some groups called it kinnikinnick, some groups called it other names. But the one account I found was interesting. They said certain groups of Delaware Indians, they used so much sumac in their tobacco combination that scouts and other people nearby, they could tell that this group of natives were in the neighborhood because of the odor. It was so distinctive.
Really?
That sumac leaves give off such a distinctive odor. And I can tell you, when we did burn it, it smelled so god-awful.
Oh, I do have a little thing on that. According to John Eastman, an author that we like that wrote the book of Forest and Thicket, Staghorn Sumac is not a good firewood. He says it throws sparks.
That's right. They said it's more like a fireworks show. Or something. So don't burn it.
Right.
Let's talk about the berries and who eats it.
Sure.
So I got over 100 species of birds are known to consume it.
That's what I think I read in Eastman, but what I found in a separate study was that about 300 songbird species include sumac in the diet. So it may not be an important part of the diet, and in fact, it's often referred to as, its only importance is as a supplementary or secondary food. It's like an emergency food for wildlife.
Yeah, and I think Eastman said if extensive feeding of sumac is noticed, that means preferred foods aren't available.
Yeah.
Like if they're picking out on sumac, that's not a good sign.
Yeah.
So they're scraping the bottom of the cupboard.
Sure. Did you want to say what some of the birds were, or should we?
Well, you know who it's going to be. It's going to be grouse.
Well, I have the list of all 300 here, so let me start. So ring-necked pheasant. Oh, sorry, spoiler alert. Ring-necked pheasant, ruffed grouse, wild. You do not like to cut me off, do you?
I was going to let you keep going. I wanted to see how far you were going to go with that.
I have 10 birds written down.
I think Eastman said that cottontail rabbits, when they eat the seeds of sumac, that seeds will germinate faster.
Right, and it's not just them. There's a couple other...
Did you find any studies on that, though? I tried to find studies.
Right, what I have is the germination of sumac seeds is actually enhanced by the passage through the digestive system of rabbits, ring-necked pheasants, and quail. So those are at least 3 that have been studied. That's all I...
So they benefit when they're scarified.
Right.
We
yes.
talked about this in the last...
stratification last episode, and this episode, scarification.
Scarification.
Right.
All right.
I don't know if we left it in or if we cut it out of the last episode, but we'll say that scarification, it's an important part of a seed's germination. The seed coat needs to be ruptured in some way.
No, but not all plants require
No, not all plants.
scarification.
Only some plants do. Well, if it's part of its strategy to spread its seed, it's going to be edible, and it's going to let animals know that it's edible, and those animals have evolved with it. And so, yeah, if it needs to pass through digestive system, or if it needs to get far away, it's going to want to be eaten. So
Sure, that makes sense. Where were we? Oh, we were talking about who eats it.
Oh, yeah. So I have white-tailed deer. They eat the seeds, the twigs, and the foliage. Skunks eat the seeds. Moose eat the twigs. Cottontail rabbits eat the twigs and the bark. And fox squirrels eat the bark. I don't know. I imagine other squirrels might eat the bark,
Oh,
too.
I imagine, too.
Yeah.
And I think we should mention, we haven't, this is a native.
Right.
Yeah. Now, talking more about the fruits, we mentioned the word drupe.
Mm-hmm.
Okay, so this is one of those terms that, being someone interested in plants and wildlife, it's a term I came across a lot, but I never looked it up until this episode.
Okay.
So this is what I found. The definitive characteristic of a drupe, and think of plants like plums, peaches, cherries, mango, even almonds.
Okay.
The definitive characteristic is that it has a hard, lignified stone, also called a pit. And lignin, that's what gives trees their stability, their hardness.
Right.
Is their cells stiffen with lignin.
Mm-hmm.
Their heartwood in the middle of a tree. So that's why a peach stone is so hard. And that lignified stone is derived from the ovary wall of the flower. Other fleshy fruits may have a hard enclosure that comes from the seed coat, but such fruits are not drupes. And you can think of an apple seed.
Okay.
So that is a hard coat.
Right.
That's a pome.
Mm-hmm.
Not the same thing. Kind of what I took away is that if it's a drupe, it's kind of like embedded, and it takes a little effort to get the seed out.
Sure.
Because it was part of the ovary wall.
Okay.
So, and maybe it seems too obvious to you, but in taking people on hikes, a lot of people don't realize that flowers become fruits.
Oh, I was eating an apple yesterday, and I took a bite of it, and right in there you could see all the anthers, all the filaments, like at the base of an apple where it has, what would you even call that? I guess where like the sepals. How do you describe that part of an apple?
Right.
It's like the butt of the apple. Sure. So at the butt of the apple, if you just cut that in half, just look inside, and you'll see the male parts of it, and obviously the female parts have expanded into what the apple is, but you could still find the male parts. And on strawberries, I think every time I eat a strawberry now, I notice the anthers and and everything else, and same thing with apples. Apples and I think strawberries are the two biggest ones that every single time I notice.
You notice that? Oh,
yeah,
this was a
male
flower.
Parts. Yeah, right. Because there's the proof. The proof is right there.
Yeah. All right, so
I just sort of mentioned a few things about the mammals and which mammals eat it, but it turns out that it's not the best food for mammals all the time. And I'll explain that using a study with white-footed mice. So this study is sort of looking at a phenomenon that happens in summer, so it wouldn't be something that's going on right now. They did this study, and they want to see what was a big part of the white-footed mouse's diet. They looked at a bunch of native fruits, and then they also looked at honeysuckle, so the one non-native. And like we said before, it's Lonicera. And what they found, and this was surprising to me, that honeysuckle was consumed less than every single native in the study, except Staghorn Sumac.
wow.
So all the natives beat honeysuckle except for Staghorn Sumac, which was less. But there could be a reason for that. So from March to November is the white-footed mouse's breeding season. And during the breeding season, you're going to be losing water, through lactation and because of their high-protein diet, which I didn't know anything about this high-protein diet. But apparently, when white-footed mice digest protein, what it does is it actually increases the amount of water loss in the urine. And the reason it does this is because it's trying to remove these toxic byproducts that end up happening through the digestion of certain proteins, right? And so the summer diet of white-footed mice is largely arthropod-based, which I didn't know.
I didn't know that either.
I didn't know that. And that's a high-protein food. Honeysuckle fruits have a relatively high moisture content, so honeysuckles usually doesn't really have all that much benefit to wildlife. But in this case, with white-footed mice, it is better.
They need something to drink.
because they need that water content.
Yeah.
And Staghorn Sumac, it's the least consumed out of all of those.
I believe
by
that.
the white-footed mouse. It has a low moisture, and it has actually the lowest amount of kilocalories as well in this study out of all the different fruits. And I should just mention what the other ones were: black cherry, southern arrowwood, so that's a viburnum, and winter grape, and northern dewberry as well. So those four natives, and then again Staghorn, and then again Lonicera. Okay, so do you have any? I mean,
Do you want to walk a little bit?
Yeah, I was going to say we should walk.
Why don't we walk a little bit? See what else?
Oh, hey, cottontail.
Oh, yeah.
There we
Looks like
go.
a little one.
Yeah, and we did talk about cottontail in our studies. It's always nice to see something that you just talked about, especially with mammals. We did a mammal episode. I think we saw an eastern chipmunk.
Yeah, that was it, I think.
Yeah.
Now, as far as non-consumptive uses, I did read some birds will cache seeds and other foods inside the berry clusters.
Okay.
So, you know what? I'll try to look that up, and we can write an episode note to see if that is correct or not.
Sure. This is disgusting, but when I was a kid, I used to eat Staghorn Sumac.
Why is that disgusting?
No, well, I'll explain. Growing up, I didn't like touching worms. I was like a very, I didn't like things that felt gross.
A squeamish kid.
I was a squeamish kid, right. And so we decided, hey, let's just save some sumac for later. So we brought some Ziploc bags. We snapped some sumac right off the trees, and we put them in these Ziploc bags.
Okay.
We had them on our porch or something for down at my cabin. We had them on the porch for a few hours. We came back to them, and suddenly the bags were crawling with what I assumed at the time was worms, but really what it most likely was like larvae of different insects and whatnot. But it was still disgusting, and ever since then I never ate it again. I was just picking fruits off of that and eating it.
Well, I love that you brought that up now, because I was going to save this for later in the podcast episode.
Sure.
But I actually made some sumac tea, and I want you to try it.
Sure, I'm totally for it.
All right, so let's do that now. Do we want to give the recipe here, or should we post that online and people can look it up?
Oh, you could. How about as you're getting out of your backpack, you can talk about it.
So you have to gather the berries, and the rule of thumb is you get 1 cluster of berries for every cup of drink that you want to make.
Sure.
And then when you bring the berry clusters inside, I usually just use a big soup pot. And I'll gently squeeze the clusters just to kind of bruise the berries to break some of the hairs.
Okay.
And I put the clusters into the big pot, and then I put in, as much water as I need. If I have 4 clusters of berries, I put in 4 cups of water, maybe a little more.
Okay.
I use just cold water. You can use hot water. That'll draw things out quicker. But to me, it gives it more of a bitter flavor. So I just steep it in the cool water for, I don't know, as many hours as it until it starts to look a deep red color.
Okay.
And then I use a coffee filter, and I strain it through a coffee filter. And then it's ready to go.
Okay.
So
can I tell you a couple things about this?
Yeah, go ahead.
So it's very likely that this drink is going to be high in ascorbic acid, malic acid, vitamin C, vitamin A, and I actually think it does have some fat and some tannins in it.
Oh, it definitely has tannins in it.
Right. So each cluster of drupes may contain, so each group, that thick panicle that you see at the end of a branch, that has about 100 to 700 seeds in it.
They're densely packed.
Very densely packed. And I guess how many seeds do you think you would have if you weighed out a pound?
Oh my God. 5,000.
60,000. Yeah, and just one thing we didn't mention before: the fruits are produced on the plants at 3 to 4 years of age. So it takes the trees a few years to start producing.
So each clonal stem.
Is this frozen, or is that like?
Well, I've been carrying it around all morning, so it froze a little bit in my backpack. All right, so first, try this one.
Okay.
I have two jars.
Tell me you put honey in one of them or something.
Okay, so this one is unsweetened.
Okay, unsweetened. That's not bad.
No.
That tastes better than unsweetened tea. And
Yeah.
I do like iced tea that's unsweetened. I like it.
I make this on a regular basis. I like it. Yeah. So this one, the next one has honey in it.
Okay. You can tell it's different. It almost looks like honey. It looks like very watery.
It's cloudier.
Honey.
Yeah, it's cloudier.
And it smells really good. It smells like honey. Oh, I don't even know which one I like better. I think I like them both. I might like this one a tiny bit more, but
they're good.
I almost feel like I can't really afford honey all that much. So, hey, so when you were doing that, ooh, watch out!
Oh, it's dripping.
So when you were making it, did you come across what I came across? Did you come across, I don't know, dead insects? Well, my insects weren't dead, but you collected them recently, right, in the wintertime. So maybe I don't think there'd be anything that's alive in there.
So
I could be wrong.
That first jar that was unsweetened,
yeah,
that was the one that had lots of old insect larvae in the bunch of berries.
That ended up in your.
No, I'm just kidding.
Oh no,
I'm kidding.
I was wondering. Well, I was serious. I don't know. Like you would imagine that all the insects that I found in my plastic bag would have gotten out of there.
Right.
That's like a normal part of their life, and normally they're not going to stay in there until they die. They're going to get out and they're going to mature into their adult forms and everything.
So
yeah.
I will say that when I went out to pick the berries after researching this episode, there was a great description. I think it might have been in Eastman of saying if you go out in the winter and you pull out the berry clusters, that they're going to be mined by insects. You're going to find piles of frass, which is basically insect waste.
So I just...
No. So what I did is I went out and I gathered probably 10 berry clusters, brought them back to the house. And the ones that were seriously mined,
sure,
I could see insect frass. I didn't use those.
Okay.
The ones I did use, it's possible that something was in there.
Ooh, it tastes like insect frass.
But, again, you're running it through the coffee filter.
Right.
And is that stuff poisonous? I mean, it's highly unlikely that any of that stuff would be detrimental.
Yeah, I'm pretty sure that on a daily basis you eat worse stuff than that. So there is something I do want to talk about since we're talking about the fruits. And so, do you know about these sex ratios?
Yes.
Oh,
but go ahead.
Okay. So you'll find that there's male clones are more numerous than female clones most of the year. Like that's most of the time you're going to find that male clones, there's just more of them.
Right.
And so there was this study from 1988 from Ecology that I found that I thought was pretty interesting. And so what it was more or less trying to say was that the female sexual effort is usually, in most species, more costly
Right.
Than the male reproductive cost.
Let me jump in.
Yeah, sure.
Because that's called the cost of reproduction hypothesis.
Oh, okay.
So the belief that if you have male and female individuals, the female, since reproduction is more costly, it probably is going to take more energy.
Okay.
That there's going to be some detriment.
Okay, yeah, right. Well, okay, so what they found was that the male clones, also called genets, so male clones, there's more of them. But an interesting thing about that, and this is just sort of a sidebar, is that there's fewer leaves on flowering branches than what the females have. So in general, the females will have fewer leaves by far. But on their flowering stalks, they have more leaves.
Right.
So does that make sense? Is that
does.
clear?
Yeah.
Okay. So now let's just get on to the female clones. So like I said, they have fewer leaves, and in this study they found that there was half as many leaves as in the males, except for on the flowering branches, and they also had a third of the number of the branches on a trunk. So, and of course, when you have a third of the number of branches, you're going to have way fewer of the number of flowers as well, because there's less branches, So, and they actually point that out. There's like, of course, because there's fewer branches available to bear flowers and fruits. But the one thing that they did find is that even though there was these differences in reproductive and foliage and everything, they actually had the same, males and females had the same annual trunk increments.
Right.
Yeah, and I thought that was really interesting.
So the trunks are the same size.
Right, and so the females are not suffering as a consequence of this greater reproductive stress.
At least in terms of trunk diameter.
Just in that.
Right.
Did we look at the same study?
I think we did look at the same study.
Because this gets really cool, I think. I think this is where it starts getting interesting.
See, I think when I reach this point, I'm like, this is just too confusing. And Steve's thinking, this is so cool, and you keep going.
Sure. So I'll throw this in too. Even though there's half as many flowers on the female, the fruits have 6 times as much biomass as the male flowers. One thing that females do is that females may hold on to their leaves longer, or they may actually flower less than the males. And holding on to the leaves longer is something that we saw with multiflora rose, where in the fall, it'll keep its leaves a little bit longer than some of the other trees that are blocking its sunlight from the canopy.
But is sumac doing that? Is the female sumac doing that? Is it holding it onto its leaves longer because it has the fruit that needs to be dispersed, so it wants to flag its fruit?
Oh, that could be it. That actually, the flagging could explain that a little bit. Yeah. So there is this one really interesting part of the study. My favorite part of the study is that female genets or female clones are more likely to be vegetative or dead.
Okay.
And I think this is maybe one of the more interesting parts. And there's a couple hypotheses that they have of why this might be the case. So maybe they're dead or vegetative because they're under more reproductive costs, more reproductive stress, and so they just can't afford to flower. They can't afford or maybe they try to, and just there's a loss there somewhere, and the plant doesn't end up making it. It just dies. Right. So that's why maybe there's more dead stems or more vegetative stems. But there's another hypothesis that's really interesting, and that is a flowering female may draw nutrients from its surrounding clones.
Oh.
This is why you have to read the discussions on every paper, because this is where they get into some of this really interesting stuff.
So like this clone is saying, all right, sisters, like I'm fruiting, so I need some of your
juice. Like one of us has to fruit, okay?
Yeah.
And I'm going to sap some energy from you guys, so you're either going to stay vegetative or you might die.
Because technically, they're all the same plant.
Right.
They're just different.
Oh
shoots
because they're
plant.
all clones and they're attached from underground.
Yeah. So this stand of sumac next to us it could theoretically be one plant.
Right. Yes. Yeah. The interesting part of the study is that there's different costs and patterns of reproduction in male and female trees. So like I said before, the females may flower less, they may hold on to their leaves longer, they may be sapping nutrients from surrounding clones. There's just a lot of things that they have to worry about that maybe a male tree wouldn't have to do. The male tree just has its flowers, sends the pollen out. Yeah.
Now, I did find a review that was really looking at the cost of reproduction hypothesis, where it looked at a whole bunch of studies.
Sure.
Now, what they found is...
let me just... I want to remind everyone, my study was from 1988.
Okay.
So I don't know. Like, because there's been a lot of years since it's almost 20 years off now.
Well, I think we should point out to
or
people...
more than 25 years.
We had a hard time finding a lot of research on sumac.
Oh, no one wants to talk about sumac. In fact, the vast majority of the studies were studies with other species.
Yep.
It was hard to find a study on sumac.
Right.
So
this review that I found said that for woody species, generally speaking, females are smaller. If you have dioecious species where you have female plants and male plants.
Two houses, male house or female house.
Right. Then the females will generally be smaller, although with sumac, it's not the case. It doesn't look like.
Apparently, the females are a little bit smaller until about the age of 6, and then they catch up and they actually grow at a little bit of a faster rate
in late
than
succession.
The males.
There isn't a big difference.
Right.
But then they found in herbaceous plants, when you have dioecious herbaceous plants, there isn't a difference in size. So there doesn't seem to be a huge difference.
That's interesting.
Yeah. So and it didn't say why. It said we don't really know. This is an area of more research.
Oh, so do you have something else? Or can I? I have a jumping off point. So, going off of finding a conclusion to a study without having a explanation, I actually have a really interesting one about road salt and Staghorn sumac.
Okay.
So, so this study was done in Massachusetts, and this is actually, I didn't know about this. So in Massachusetts, 240 pounds of salt and 12 pounds of sodium chloride, so NaCl, per lane mile. So what that means is that for every mile of road that gets salted, you're putting out 240 pounds of sand and 12 pounds of salt, road salt. So this is a lot.
Frightening.
The real danger is from the salt spray from the cars and from plows. And the roads, they're being salted, and 10 to 25% of that salt is traveling through the air, and it's actually found within 30 feet of the road. Which happens to totally match up with the most severe damage to foliage on plants is within 30 feet of the road. So I guess burning and browning of the leaves or needles is really how you're going to see it, and you're actually going to see more damage on the side of the tree that's facing the road.
Of course.
Right.
And where does sumac grow very often?
right on the edge of things. And so a road through a forested area, you're going to potentially have sumac on the side. But now we're going to see that they do very, very poorly within 30 to 40 feet of the road, just any road that's salted, that is. So pines are especially sensitive to road salt injury. So pines are not really good at it. The thing is, they're fine if the salt is in the soil. For one reason or another, they're fine. Well, think of acidic soils.
Yeah.
They're usually a little bit less nutrients and everything else. So the problem is when the salt lands on the leaves, because it's causing this like osmotic effect that's drawing the water out of the leaf.
Okay.
So it has this effect that if you I don't know, take plant physiology or something, it's going to be called plasmolysis, where the leaves are going to be sort of pathetic looking because the water's drawn out of them. They're a little bit limp. They're not doing very well at all. So there are some salt-tolerant species. So this is going to be like various oak species, Quercus. You're going to get maples, Poaceae, the family for grasses. There's some ferns and yarrow. Just the little herbaceous plant yarrow.
Achillea millefolium.
What is it?
Achillea millefolium.
Look at you. So sodium concentrations in the leaves, actually, that did increase with the closeness to the road. So that would be true for pines, grasses, oaks, and sumacs. Like I said, in the soil, there was some changes, obviously. So the salt concentration is higher, the electrical conductivity is higher, and pH were higher, so you're going to get more basic as you get closer to these roads. But what does the salt do? There's something in soil, especially in this area, called colloids. It's going to be sort of the clay part of the soil, and it's negatively charged. So it has these positive charged cations that are in the soil attached to that. The thing is, those colloids like sodium a little bit better than they like a lot of other nutrients that you'd find in the soil. So when you have sodium coming in, it knocks a bunch of other stuff out, and it just washes off the land. Anywhere where there's too much salt, it just washes off that and goes somewhere else. So I guess with salting and then with runoff. So you're going to be losing a lot of nutrients that the trees would normally be taking in through their roots.
So the health of the soil degrades.
Right. So all that is to say, and I know this was a big tangent because I haven't really brought up sumac, but sumac is like the one broadleaf plant in this study that showed a huge decline due to salting the roads. So what it found is that sumacs had less than 10% of their leaves remaining on the plant.
Holy cow.
And the amount of sodium in the leaves were higher as you got closer to the road.
Right.
So, and then I searched the whole paper. I read the whole thing through. They don't explain why. So again, this is a study from Communications in Soil Science and Plant Analysis. That's why they really focus on the soil a lot. But it's from 2006, and I didn't find anything new about why sumacs have this salt intolerance. But I thought it was interesting, and they're really doing poorly near the road.
And man, here in the Northeast, salting is oh my gosh,
all over
so
the place.
Common, yeah.
But do we use sand mixed with our salt, or is it just salt?
It depends on the municipality, because I used to live out in a rural area, and they used more sand than salt.
Sure.
But most of the trucks I see around here, I see a lot of salt going down, and I don't see a lot of sand on the side of the road.
Okay.
I do have one last thing I wanted to mention, because we talked about having difficulty finding studies. Most of the studies that I found that were current were from China.
Okay.
Because sumac is an invasive over there.
Okay. Should we say spoiler alert before you tell us what? Maybe someone didn't read the study. You're just going to knock me out one of these times.
Okay, spoiler alert.
Okay, spoiler alert.
If you're reading the Forest Research Beijing journal, this is going to be old news to you. So this was in 2010. Now, I loved the depth to which they conducted this study. So they were trying to look at the allelopathic effects of sumac. So, Steve, tell everybody what that is.
A plant will release certain chemicals into the soil that'll actually make it either impossible for other plants to germinate there, or it'll actually make the plants suffer in a way where they may actually just die out around this plant. So yeah, I know some plants actually have this with, like, I think goldenrods have a little bit of an allelopathic effect.
Black walnut
does.
Yeah. So what they did is they used a water extract. So they would take fresh leaves, and they made a water extract of unbroken fresh leaves, broken fresh leaves. Mm-hmm. Then they used dried leaves, broken and unbroken. And then they also used a water extract of soil from under sumacs.
Sure.
And then they tried to germinate different plants in the presence of these different chemicals. So these different extracts. So what they found is most of them really didn't have much of an effect. The water extract from the soil really had no effect at all.
Okay.
They said the most significant one was the broken fresh leaves. So with an extract of that, I think this is one of the plants they looked at. Brassica.
Okay, so mustard.
Chinensis. So what do you think Brassica chinensis?
Chinese mustard, I guess.
So it's actually Chinese cabbage. It's bok choy.
Oh, really?
Yeah.
Bok choy.
So I
like bok choy.
They were really doing this because they wanted to see, is sumac affecting growth of commercial plants like bok choy and wheat. They also looked at wheat.
And so is it invasive over in China or no?
It is.
It is.
It's considered invasive.
Right.
So what they found is that it reduced the germination potential of bok choy to 5%.
Oh.
So it dropped huge.
What's it normally at?
I don't know. I should know.
It's usually at 6%.
But they said it. But then no, they said it was a significant reduction.
Right. And that really does mean something. So.
They said it was similar for wheat seeds, and that 4 native trees were similarly impacted.
Okay.
Now the other interesting part of the study was that when they took the water extract of the surface soil, it showed no inhibition of seedling growth or germination, but it promoted the growth of Chinese mahogany.
Huh.
So the Chinese mahogany tree did better when they took a water extract of soil from under sumac. And these are not plants that have evolved together. But
that's weird.
For
That's
some
cool.
reason, yeah.
Life hack.
Yeah, there you go.
Yeah.
So, as I said, most of the studies that I found from recent times were looking at interactions between sumac and plants in China.
Cool.
Because they're looking, it's a problem over there, so they're trying to figure out what's it doing, why is it a problem, and how can we address those problems.
Right.
And that is it for me on sumac.
Yeah, I think I'm done with everything I had too.
All right. So, as usual, we want to tell people to check us out on Facebook and our website.
Right.
Recommend us to your friends. If you can leave a review on iTunes.
Right.
Because it is available to download through iTunes.
Mm-hmm.
So
give us a share. Tell your friends about it if you think they're like-minded individuals. And
if you have ideas for future episodes.
Oh, for sure.
Definitely. And let us know what you think about the shorter episodes.
Right.
Do you think that's a good idea? We're trying to encourage more people to listen to the podcast.
Right. And these last 2 episodes, I do fear that they're going to be a little bit over a half hour. And so the goal is to get them down to a half hour. And you may see slowly we may get closer and closer to a half hour. We're going to try to get better at that. But that's what the plan is.
Well, folks, thanks for listening, and we'll see you next time.
Yep. See you then.